Hey guys, my name is Justin, and I'm going to give a quick tutorial on creating a Eurorack module using the EasyEDA software, which is affiliated with the JLPCB's website where you can order your printed circuit boards. I'm just a hobbyist, but I've had some success with it, and I thought I'd pass that on. This tutorial assumes that you've already downloaded and installed your EasyEDA software, and you are ready to go. We've created an account and everything. We'll go ahead and start a new project by clicking here. We'll call this project Eurorack Active Multiple. I've went and searched Google and found a simple active multiple circuit, so that's what we're going to use as the basis for our project. Let me go ahead and show that to you here. There we go. So it's real simple. You got your op amps. This circuit calls for LM324s. We're just going to use the good old TL074, which has 4 op amps in it. So we'll just use that for our circuit, our schematic, and you'll see we got 1 input and 3 outputs, and just a few resistors. And this power section, I'll replace this with an actual Eurorack power section. Show you how that works, power supply, and we'll go from there. So go ahead and switch back here to EasyEDA. So the first thing we're going to do is we're going to start adding some components in here. So the first thing you saw was that we needed an op amp. So we're going to click down here under library. Well, first let's go over this library. This library here is the basic stuff that you'll need to get started. And I'll go through some of these as we progress through this project. You got your basic resistors. You've got your basic capacitors, you got inductors, you got some connectors, we'll be using those, you got switches, you got LEDs, diodes, and then you got your basic transistors. Okay, so you'll notice that there's a lot of stuff in here, but not everything's in here. We're going to have to do some searching to find appropriate components that we're going to use for our project. If you look down here, you'll see the title area of the schematic that we're creating. So let's go ahead and rename this one. We'll call it Eurorack Active Multiple. There we go. Alright, so the first thing we want to add is we're going to add that op amp, which we don't see here in this this list of components. You got some voltage regulators and some displays, but we don't have any op amps. So we're going to go over here to the library. Okay. So these are some libraries that I've created, but we're not going to use those. We're gonna search here for TL074. Hit enter, and we'll get a big search. You'll notice that we have LCSC. I believe that's the online supplier for JLC PCB. So they have components that fall under that library. And then there's if you're going to get your board assembled, you would want to choose from this list. And then you've got system, there's 56, and if you look all the way at user contributed, we've got 420. So basically, user contributed are schematics and footprints that different users across the world have contributed to EasyEDA. And we're definitely going to be using some of those contributed library, some components from this library, because there's some good stuff there that you'll find for Eurorack. We're going to go ahead and look here at this one. So you look at the footprint here, it's telling us that it's an SOIC. So that's an SMD surface mount type component. If I click on it here, you'll see that this is a surface mount. We want to do through hole for this simple module, so we're not going to use a surface mount type component. So we'll go ahead and scroll down. If you look here under footprint, you'll see DIP 14. That's what we're looking for, right? And there's lots of different variations on this. Okay, so this is op amp 1 on the whole chip, right? So the chip is a TL074, which has 4 op amps. So each op amp has its own schematic. Okay, now this one, if you look, each op amp has its negative input, its positive input, and its output, as well as the plus and minus rails for the op amp. So there are different schematics where only one of them has the plus and minus, and then there's schematics like this one where they both do. I mean, all 4 of them do. So we'll go ahead and use this one. We'll click here, and then you'll see down here we have our component. For now, we're just going to place it, right? Place one, and then we'll click on the next one. Place that one, click on the next one. Place this one, and click on the next one. Place that one. So now we have our 4 op amps. I do want to show you one thing. If you look down here, this op amp is titled U1.1, right? So that's chip number 1, op amp number 1. Chip number 1, op amp number 2. If I click again, I'm going to get chip number 2, op amp number 4. It can be a little confusing, but if you want your circuits to all be on one chip, you need to pay attention to that, right? So if you have multiple TL74s, you need to keep track of which ones, how they're numbered, and which one does what, right? So I'm going to go ahead and close this screen out, right? We're not going to use this 5th op amp, so I'll click on it and hit delete, right? So that's simple enough. Now we're going to start arranging our op amps on our sheet so that we can more easily work with them. Now the schematic I'm using is a little confusing to me, so I'm going to go ahead and redo it as we go through. Not really confusing, just drawn in a different way. So we'll go ahead and start making our connections to go with that schematic. Let me switch back to that real quick here. So you'll notice that pin number 4 and pin number 11 on this chip, which in this case they're using, now in this case they're labeled 1 Bravo or 1B and 1A, A, B, C, D instead of 1, 2, 3, 4. So that's something to think about when you're converting your schematics and your redrawing schematics. You might have different labeling. So let's go ahead and go back. Now we know that the pin number 4 is supposed to go to the positive 12 volts, and then pin number 11 goes to the minus. So over here we have our plus and minus, our VCC and our plus 5 volts, and we also have ground. These are 3 things that we're going to use a lot of, right? So let's click on our plus 5. I know we're not using, this is not plus 5, but I'll explain in a moment. So I'm going to zoom in a little bit. I'm going to put the plus 5 right there. I'm going to hit escape. That gets me out of the placement of the components. I'm going to double click on it and I'm going to change it. I'm just going to call this plus 12. Right, now I've got plus 12 volts. You'll notice that it's not connected. Alright, so what we can do is we could just drag this down and now it's connected. Now if I lift it, you'll see that it draws a wire between them. If I move this around, it will remain connected. The only way to unconnect it is to click on that wire and hit delete, right? So if you want it, now you'll notice if I put it here, it's going to overwrite the label for that chip, and so I don't want that, so I'm going to put it one up, and now I want to connect these two. I would click on the wire here and just connect them. Simple enough, right? So now, because of the way these schematics are, I need to add that 12 volts to each of these, right? So the quick, easy way to do that, I'll hit escape to get out of the wire mode, and I'll right click on this and I'll copy it, and then I'll paste it. Boom, it pastes it wherever my cursor is. And since it's still in the buffer, I can paste it again, a control V to paste, right? And I can paste it again. Boom. Alright, now I can click on the wire button here and connect them. Alright, so now they're all connected, right? Now we need our negative 12 volts. So what I'll go ahead and do is I'll paste that again, right? And I'm going to change this to, you guessed it, negative 12 volts. Just change the plus to a minus, right? Now we've got negative 12 volts, but it's facing the wrong way. So I'm going to click on the item. You'll see that it's highlighted, and I'll hit the R key, rotate twice, right? That gets us around to the bottom. There we go. Now I'm going to copy that one with a control C, and I'll do a control V to paste it. Boom. Paste it up here. Paste it up here. Okay, so now the power supply to the op amps has been taken care of. Okay, we still have to do our power section, which actually controls where the 12 volts comes from. But for right now, we've labeled the everything correctly. So let's look back at our schematic. Where are we at here? Oops, lost my schematic. There we go. So you'll notice, like I said, it's a little confusing. I would have put this input on this side, and that's what we'll be doing. But if you'll notice that we've got a 1K resistor that goes into the positive input of this this op amp. Now, one thing to talk about, my op amps are not in the exact same order, right? But I am going to call this one input, and then these are going to be the 3 outputs. Okay, so I'm just going to use this first op amp, which uses pins 1, 2, and 3 as the input for this circuit, just to make it a little simple. Alright, so we know we see here we have a 1K resistor that goes into the positive section of the first op amp. Right, so we'll go over here and we'll click here. Now you'll notice that it has R axial 0.3 US. That's telling you what the footprint is for this specific component. If I click down, you have a bunch of choices here, right? The 0.3 references the width of the component. The R axial is an axial resistor, okay? If I choose one of these, it will be a surface mount. So a 0603 or the 0805 or the different standards for surface mount components. But we're going to stick with this 0.3, right? So I'll click on the resistor, and you'll notice that now my cursor has a resistor, right? And we want this to go into the positive portion of this op amp. Alright, so I'll click on it to connect it, and I'll right click to deselect that item. Let's go back and look at our schematic again. So this schematic uses op amps with the positive on the top and the negative on the bottom. The schematic we're using is the opposite, so we're not gonna we're gonna connect it as this is written, but it's gonna look opposite on our schematic, just so that you're tracking. So the 1K goes from the input and it goes into the positive, right? And there's also a 4.7 meg ohm resistor that goes from the positive input down to ground, right? So we still need to connect that one. So what I'm going to do here is I'm going to move this out a little bit so that we can do that a little easier. And we're going to click on the resistor again. This time I'm going to rotate it by typing the key R, which is rotate. Now, when you have more than 2 components connected, you get this little button, this little dot, right? So that's telling you that these two are definitely connected. If it's not there and there's more than 2 components, then that's telling you that something's not right. This is R1, which is 1K, that's what we want, but this one we want this to be 4.7 meg ohms. So I'm going to double click on the 1K part. I'm going to type 4.7 meg. Right? That's how I do it. You'll notice in that other schematic it had 4M7. That's just another way of saying 4.7 meg ohms. So now what we need is the ground. This goes to ground, so I'm going to go ahead and choose this ground symbol up here, and we'll go ahead and place that right there. So now we've got that portion of this schematic done. Alright, let's go look. Alright, so let's go look at our schematic real quick here, and you'll notice that the negative is connected to the output, right, just with a wire, no resistors or anything. So let's go ahead and do that. The way we do that is we're going to choose the wiring tool, which is also the key W on the keyboard. We're going to click on, wait till we get that little dot showing that we're connected, and I'm going to run this around over here. Boom, okay? So now the negative input on this op amp is directly connected to the output, which is what we want. Alright, so now if we go back to our schematic, we'll notice that the output of this op amp goes to the positive input on all 3 of these op amps, right? No resistors or anything like that. Alright, so we need to connect the output of this op amp is going to wire down to this one. You see that? Let me scroll in a little bit, maybe you can see better. And then that's going to, oops, I messed up, didn't I? Because it's supposed to go to the positive. So I'm going to click on escape out until I can click on that wire, and I'm going to delete the wire, right? And I'm going to hit W for a new wire, and this time I will connect it to the op amp. Alright, so let's talk real quick about wires. As you're moving your wire around, if you click a location, it will anchor that wire there. If you don't click a location, the computer will try to just do the best it can to route that wire. So if you want it to go a certain way, then you need to tell it that by clicking down where you want it. So I'm just going to wire up all the positive inputs of these output op amps and go from there. Now we need that same, if we look back at our schematic here, we need that same we have a 100 ohm resistor on this side of the output, and then the wiring goes back to the negative input on the op amp. So let's go ahead and implement that. Let me show you how to do that. So we're going to need another resistor. I'll click back here and we're going to put it here. Since we need 3 of these 100 ohm resistors, I'm going to go ahead and hit escape. I'm going to double click here. I'm going to change it to 100 for 100 ohms, and then I'm going to copy that one. That way I don't have to change the other 2 from 1K to 100 as well. Okay, and then what we want to do is we want to wire the rest of these feedback loops here. Oops, let me start again. And I'm going to run it around to this side. Boom. Okay, so now we've got most of our schematic done, right? If we look back at our schematic, we have the outputs, the output jacks we still need to connect, and then an input jack as well, and then we got to deal with the power section, right? So let us go ahead and talk about the jacks real quick. So we want this module to be pretty skinny because it's just a simple 1 into 3 multiple. So we're going to use jacks that mount directly on the printed circuit board at a right angle. So what I'm going to do now is I'm going to switch over to the TIDA website. You're probably familiar with this website. You can order components from it, and you'll see that we have a 3.5 mono phone jack. That's what we're going to use for our project, right? And you'll notice that the code is PJ323. I'm going to go ahead and copy that. And then now I will go back to EasyEDA, and remember we go to the library when we need a component that's not listed, right? So I'm going to click up here and I'm going to type in, hit Control V to paste in that PJ323, and I'll hit search. Now the search can sometimes take a little bit of time, right? Depending on your internet connection and how busy everything is. So you have to kind of bear with it. Now you'll notice we have 3 that are all user contributed, okay? So this someone named Unfirth, R. Goodner, and X. Qua went ahead and created these footprints and schematics. Now one thing to think about is you do need to be careful. Anybody can contribute, so you have to take a grain of salt with each of these components. Now if you look at them, the first one had a real simple 1, 2, 3. It doesn't tell you what each pin does, which one's ground, all that, right? So that one's not super useful. The second one here has a nice drawing of your typical connections that you'd see for an audio jack. So that one's pretty good. And then this one here, it also has the same, right? It looks very similar. If you look at the footprint, you'll see that the footprint is a box with 3 oval holes in it. So let's look over real quick at this. It looks like it's going to fit. If you look here, we have the slots here, and we can even click on the data sheet and look at that, and this is how we would create a footprint from scratch if we wanted to. We're not doing that in this case, but it looks pretty good, right? So we're going to go ahead and use that one. So when it's time to, remember when you click on it here, it's going to show up down here. So we'll click once. We know we need, what do we need? 4 total, right? So let's just go ahead and click 4 total and close out that thing. Hit escape to lose to reset the icon, or to get rid of that component. And you'll notice that these are automatically numbered: U2, U3, U4, U5. We didn't talk about the resistors, but the first resistor we placed was R1, R2, R3, R4, R5. If you're copying a schematic from the internet, it's always good to make your components match up with the name-wise. So if you need to check some issues, you can always verify that you have everything set up right. Alright, so for this one, we're going to go ahead and drag our first jack here. Now, you'll notice that they're labeled ground, normalized, and the tip, right? So in this case, the ground, of course, is going to be connected to the ground. So I'll go ahead and hit W for a wire, and I'll run that right here. Now I have two options. I could actually connect that over here to this ground here, because ground's the same all across the board, or I can just click a new ground and add that. That's what I'll do. Now the tip, we know we want it to go into this 1K resistor. Again, I'll hit wire, and I'll wire that in. Boom, like that. Okay. Now, what do we do with this norm? We're not going to use it on this. We might use it if we had, let's say we were doing a multiple, we were doing 1 into 3 and another 1 into 3 on the same module. You might want to normalize the signal from this jack down to, or you might want to send the signal from this jack from the tip down to the normalization jack on the second input. But we're not going to use it for this simple project. So we're going to click this X here, no connect flag. Any pins that you do not use on any component should have this X on it, and that I'll explain why in a little bit, but that's just generally a good rule. Now this has the name PJ323 side mount. That's not super useful, so I'm going to double click on it. I'm going to say input, like that. Alright, we're set with that. Now we're going to put 3 up here for the this one, and then we're going to put 4 right here for this output, and then we got 5 for here for this output. Alright, now what we want to do is we want to rotate these so that they're facing that way. It makes it easier to connect, right? I'm also going to line up the tip with this resistor. Rotate, rotate, 2 R's press, and then line that up. Now the nicer you make your schematics as far as lining stuff up, just the better off everything is going to be. If you do your schematic all crazy, sometimes it can be a little challenging to figure out where you made a mistake, right? So I'll go ahead and click wire, and I'll connect the tip to that 100 ohm resistor. Simple, right? Alright, and then we know we need a ground, so I'm just going to connect ground to each of those guys there. And remember, we want to use the X on any connections that are not connected. Now, for example, let's say we wanted to, you'll see that they're running into each other, so that might be a little confusing. What you can do here is if you double click, I guess you can't do that here. I'm sorry, I thought you could move it, but you can't. You can move some of the stuff, but you can't move everything on the schematic simply. And remember, if you want to undo something, you just hit Control Z. Alright, so let's rename these. This one's going to be Out 1. This one's going to be named Out 2. And this one's going to be named Out 3. Right, so we got our 1 in and our 3 outs. Now let's talk real quick about this U. So in my experience, typically the ICs are labeled with a U, but an input jack would normally be with a J. So if we want to change that, that's simple. We just double click and we put J1, right? Jack 1. And then we'll change this one to be Jack 2, and then Jack 3, and lastly Jack 4. Let's go back and close out the TIDA. Now if we look at this one, I don't know what happened to my schematic. Maybe I missed something here, but this is supposed to be wired in the feedback loop here. There we go. So now it matches. Here you'll see that this pin number 7 is going around to the negative input. Alright, so now we're back at our schematic. Our schematic is done as far as the actual component, the non-power related components. We've got our feedback loop going for each of these op amps, and we've connected them. I didn't pay particular attention to which one is connected to which, because it's going to be simple on such a simple circuit to connect it as we have it. However, when you're doing a more complex circuit, you'll want to pay attention to which op amp is connected because sometimes that can make all the difference when it comes to routing our connections in our printed circuit board. So the final thing we're missing here is our power section. So we could go over here to the library and we look down here and we have connectors, right? So if I check this header here, we have a header IDC 2.54 2x5. That's your typical Eurorack header, right? So I can click that and I can add it. The problem, not really a problem, but my one consideration is that this is an unshrouded header, right? So if at this point, let me switch over to, first we got to save it, right? So I'm going to click up here and save our work so far. And I'm going to switch to the printed circuit board view really quick. So I'm going to convert the schematic to a PCB. We're going to talk about this in a little bit in more detail. But first I'm going to click that. It's going to ask me if I want to check the nets. I'm going to say no for now, just so I can show you what I'm talking about here. Alright. So if we look at our rough printed circuit board, these are all the components that we've created so far. This one is actually, it is a shrouded header. So we're okay with that one. I thought it was an unshrouded header. But this one happens to be shrouded. You can see that it has the layout for the shroud, which is more safe when we're creating a power supply so that we don't accidentally plug our module in backwards, right? So let me go ahead and close that out without saving it, because we're going to cover that in the next video. Alright, so we have our power header here, right? It's P1. We're going to go ahead and double click here and we're going to call this power. I'm going to rotate it twice. The reason being, pin number 1 on a Eurorack is connected to what? It's connected to minus 12 volts. So I want that to be on the bottom here, right? So I'm going to go ahead and wire pin 2 and pin 1 together, like this. Right? Now I'm going to wire pin 10. Oops, I missed it. Pin 10 and pin 9. If you mess up on your wiring, you just hit the escape key and it will kind of reset it. Right? And then we know that the ground pins on the Eurorack need to be connected. Right? And then we need to connect these to ground. So I'm going to make a little wire come off of it and then connect that to ground. And then I'll put a ground over here. Wire. Boom. Right? You have a lot of latitude. I could have just wired these around here. Or you can do it however you like. Now we know that the top here needs to be connected to plus 12 volts. But well, that's fine. Let's go ahead and do that. Let's grab a 12 volts here from one of the op amps. I'm going to do a Control C to copy it and a Control V to paste it. And then we'll grab this minus 12. I do want to, well, yeah. You want to check that the whole thing is highlighted, right? Control C and a Control V to paste it, and then we'll add that down here. Alright, so now we have our connections for our minus 12 volts. But we want to put some capacitors in, right, for power smoothing. Now, in the modules I designed, I also put in some diodes to help with reverse polarity protection in case someone doesn't use a shrouded header, or they wire their cable up wrong to help prevent from burning out your components. But for this simple example, I'm not going to do that. So the next thing we need are some capacitors. So I'll go back to the EE library here, and we see our capacitors are here. We have electrolytic and we have radial capacitors. This one is a through hole. That's what the TH means. And if we click the down arrow, we can see that all the different choices we have. You have surface mount, a bunch of surface mount on top, and then we have a bunch of through hole on the bottom. I'm going to go ahead and leave it at this 5mm by 2mm, and I will click on it to select it. Right. So now we have our capacitor. I want to rotate it twice to get the plus on the top. Right. So it makes the most sense for me. Now I'm going to line it up so that the bottom of this component lines up with the ground. And then I'm going to add another one right below it. Right? And then I'm going to wire those up. So I'll hit escape, and then I'll hit the W key, and I'll connect those, the middle section of those two connections to ground. And then I will connect the 12 volts and the plus 12 volts and the minus 12 volts. Right? So now we have our capacitors. We'll go ahead and change these to 10 UF. You can put whatever values. A lot of times you'll see 22 or 47 or whatever you like. And then we're going to put a couple radio capacitors in there too. So I'll click over here. I'm going to use this 0.3. Again, I will rotate it, this time just once because there's no polarity. And I'll do the same thing. right? And then I will wire these in, the middle section to ground, the top to this one, and the bottom to this one. Now just a reminder, if you want to see if something's connected or not, you can click on it and drag it. If you see the lines moving, that tells us that that's a good connection, right? Now you can mess things up if you do something weird like that, right? That doesn't look good, and who knows how that's connected. So I'm going to do a Control-Z to go back to the way it was, right? Now these smoothing capacitors, we want these to be 0.01 UF. So I'll double click here. I'm sorry, 0.1 0.1 UF. Right, and you can write whatever you want in here. For example, on this one, let's just put 100 nanos, right? It means the same thing. So let's change this one to 100 nanofarads. Right, there we go. Alright, that pretty much completes our schematic. If you look at it, we've got our power section. So when you use the ground and the plus 12 and the minus 12, the computer knows that these are all connected, right? So this ground is connected to this ground, is connected to this ground, and then the same thing with the minus 12 volts and the plus 12 volts. So that concludes the first video on creating the schematic. In the next video, we will start tackling the printed circuit board. Thanks for listening.